Welcome class to our new lesson, Heron's formula. Well, this lesson that you're going to see is not going to look like a trig or pre-calculus type of lesson, but it was pre-calculus or trigonometry that actually developed what we're going to learn today, which is called Heron's formula. Ever since you can remember, you've always had teachers tell you in order to find the area of a triangle, so how much space is being incorporated inside this triangle, you use the formula A equals 1/2 base times height. And so what the teacher would tell you or show you is you find the right angle. So here we have the right angle, and your base and height would be these two numbers that form that right angle. So you need the base of a triangle and you need the height, which is perpendicular, to that base. So if you take these two numbers, put it into the formula, so this would be 1/2 base times height. Put it in your calculator. So 7 times 2.8 is 19.6. Divided by 2, you get 9.8. And since this is in centimeters, this would be centimeters squared. Now, what would you do if this 2.8 was not even there? Let's say you had a 5, a 4, and a 7, and this was not a right angle. Maybe it's slightly obtuse or slightly obtuse. Alright, so there's no right angle in this picture, and you're given these three sides. How would you be able to find the area? Well, you would simply use Heron's formula. So what they did was they took the trigonometry ratios, and he was able to develop a formula and a proof that shows you that if you put these three numbers into this formula, you would be able to find the area. So I got another duplicate of this problem, but notice I've taken the height out, and I did do the pre-measurements, so you can see we have 5 centimeters, 4 centimeters, and 7 centimeters. But let's say we do not have a ruler in which we can find the perpendicular, and we want to find the area of this triangle, and we have no other tools except maybe a calculator. So we would use Heron's theorem or formula, and this is what it looks like. Okay, write this down with me. The area of a triangle, any triangle, so I could use this on acute, right, or obtuse, is equal to the square root of S times S minus A times S minus B times S minus C. Alright, let's start first of all with the A, B, and C. I think you can see it's pretty obvious A, B, and C are the sides of your triangle. So we would have A, B, and C. And so these three numbers would be plugged in here, here, and here. And I just usually go in order from least to greatest, but since we're multiplying, it doesn't matter which one you call A, which one's B, and which one's C. Now, let's talk about the letter S. The letter S actually stands for semi-perimeter. Now, in geometry, you learned about a semicircle. Well, when you have a circle and you take half of that circle, you have a semicircle. Well, this means it's kind of the same. Semi-perimeter means you are going to take the perimeter of this triangle and then you're going to take half of it to create a semi-perimeter. So let's find S. S is equal to 5 plus 4 plus 7. 5 plus 4, 9 plus 7 is 16. Alright, but that is the whole perimeter. I need semi-perimeter. So please don't forget to divide by 2. when you divide by 2, the semi-perimeter will be 8 in this case. Now I have everything I need. S8, A4, B5, and C7. Let's put it into this formula to see what happens. We have 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. Let's simplify our parentheses. 8 minus 4, that's 4. 8 minus 5 is 3. 8 minus 7 is 1 times 8. Now just take your calculator, put in 8 times 4 times 3 times 1, you get 96. However, we need to take the square root of that. Take your calculator, take the square root of 96, and you get 9.79, or approximately 9.8. Now let's go back to our original picture. The original picture, they gave you a height of 2.8 and the base 7. And we put in the base times the height divided by 2, 9.8. Using Heron's formula, we also get 9.8. So this is a really awesome formula that was developed, in which a height was not given, and you are given 3 sides. And the reason why you weren't offered this before is because we didn't learn about the trig really until we got into our pre-calculus course. All right, y'all have a great week.